compress this bottle, the thing will move from top to the bottom of the bottle slowly, and when we release it, the bottle will expand, so the thing will move from bottom to the top slowly. So this is the formula of the density. When we compress the bottle, the volume will decrease and the density will increase because density is inversely proportional to V. So we compress, volume decrease, density increase, and the thing will move from top to the bottom of the bottle. So when we expand the bottle, the volume will increase. Volume increase, the density decrease. So the thing.
Today we are going to do an experiment which is called ketchup diving experiment. How to control the ketchup to goes up and down the bottle. The material we are going to use is here. We replace the ketchup with other material to show you the variation of the material going up and down inside the bottle. The first one is the clove. The next one is the cardamom. And the next one is a piece of cinnamon. And also, we have a bottle full of water to put the materials before inside the bottle to control which of the material will easily goes down and up the bottle. So let's go and do the experiment. We already put the experiment material inside the bottle, as you can see here. When I squeeze this bottle, you can see that some of the stuff will stay up and some of the stuff will go down. Basically, when you squeeze the bottle, you compress the air bubble into a smaller space. This happens because gases are more squishable than liquid, so the air compresses before the water. According to the density equation, which is density is equal to mass divided by volume. When you decrease the volume or make the bubble of air smaller, you are actually increasing the density and the stuff will sink. When you release the pressure on the bottle, volume increases, making the density decrease, and the stuff will goes back up to the top of the bottle, as you can see here.
Thermodynamics is the branch of physics that has to do with heat and temperature and their relation to energy and work. The behavior of these quantities is governed by the four laws of thermodynamics, irrespective of the composition or specific properties of the material or system in question. The laws of thermodynamics are explained in terms of microscopic constituent by statistical mechanics. Thermodynamics apply to a wide variety of topics in science and engineering, especially physical chemistry, chemical engineering, and mechanical engineering. We prepare 2 jugs with hot water inside. Next, we put balloon on the mouth of the empty bottle. The last apparatus that we have to prepare in this experiment is an empty pail. Place the bottle on the hot water. Give the bottle and balloon apparatus a few minutes to get warm. The balloon will fill up with hot water and stand straight up.
The balloon expanded because when hot water was added to the pail, heat transferred from the surrounding hot water to the system, the air inside the bottle and balloon. Before the system managed to transform the heat input into work, it is stored inside the system as internal energy.
Alright, in this video, we're going to do an experiment called a stack ball drop, which our apparatus will be using a tennis ball, ping pong ball, and a ring. We're going to drop it at a certain height. So basically, when we drop it, the ball individually, each ball starts with a different potential energy from the height of the drop. As the ball hit the ground, some energy goes into hitting the ground, some goes hitting the ball. As the tennis ball or ping pong ball bounces and it compresses during elastic potential energy. During that transfer energy, some momentum will be transferred from the tennis ball to the other ball. That is, if we stack the tennis ball and the ping pong ball together. So basically, when we drop the tennis ball on top of the basketball, there will be momentum transfer in which the tennis ball will bounce back up even higher. And since the basketball starts with a higher momentum due to its, a tennis ball starts with a higher momentum due to its bigger mass than the ping pong ball, then the velocity will increase where a ping pong ball drops on top of tennis ball. The tennis ball has larger momentum, and so the velocity towards the ping pong ball will increase, and so the bounce of the ping pong ball will go higher. So
okay, today we're going to do a conservation of momentum experiment. So the apparatus that we are going to need is two balls with different mass. So I'm going to use a tennis ball and some squishy ball. Okay. And this is the normal height for this squishy ball. This is the normal height for this tennis ball. As we can see from the video, we place the squishy ball on top of the tennis ball. So as soon as the tennis ball hit the ground, all of the momentum from the tennis ball will transfer to the squishy ball, which is the reason why this ball bounce higher than before, because when the momentum transferred, it's also increased the velocity of this